Hey guys, this is Fraser from Things About Tutoring. So today we're going to be looking at this trigonometry question. Pretty long question, 8 marks. It's a paper 1, so non-calculator, otherwise it'll be a bit too easy. So the first part is trying to get us to look at a trig identity. So we have to prove this or verify this trig identity, and it's going to use the double angle theorem or double angle formulas. So the sine 2x and cos 2x. So my general rule would be get rid of the 2x's, so try and turn those into their sines and cos, manipulate those, and we should be able to get the answer. So you have this in your formula booklet. You know that sine 2x is 2 sine x cos x, and you know that cos 2x, and there's a couple different ways you can write cos 2x. I think in this case they want us to write it as 1, 1 minus 2 sine squared x. So this is how they want it to write. Obviously, you can try other ways and then you can manipulate it like this. But this is the way that you have to write it for this question. You can try other ways and you'll end up having the same answer. So we can replace this. So that means we'll have 2 sine x cos x plus 1 minus 2 sine squared x minus 1. Remember, because we've got this minus 1 over here. Equals. And then these ones are going to cancel. So it's 2 sine x cos x minus 2 sine x equals, so then we can factor out 2 sine x, and then we're going to have cos x minus sine x. And this is equal to 2 sine x cos x minus sine x, which is what they have over here. So left hand side equals right hand side, done. So that's easy, 2 marks, just have to use the double angle. Next part is hence or otherwise solve this equation. So the or otherwise means you are allowed to use other methods, but obviously we're going to want to use what we just proved. And if you'll notice, this is what we had before. And we've now shown that this is equal to 2 sine x brackets cos x minus sine x. So let's just go and throw that in there. So then that's going to be 2 sine x cos x minus sine x, and then we're going to want to add cos x and then subtract sine x, and this is equal to 0. So I'm going to expand this. 2 sine x cos x minus 2 sine squared x plus cos x minus sine x equals 0. Okay. And now, I think... Actually, no. Sorry, I shouldn't have expanded that. I realized that's actually a step in the wrong direction. What you have to realize here is that this is the same as this. So you can actually factorize that out. So then that's going to be cos x minus sine x, 2 sine x plus 1 equals 0. And now we've got it in a form we can solve. So we have 2 brackets being equal, their product being equal to 0. So we just need to solve this one being equal to 0 and this one being equal to 0, and that's going to give us our solutions. Let's start with the second one. So we want to solve, when is 2 sine x plus 1 equal to 0? Well, that's when sine x is equal to minus 1/2. And then what we have to do is I usually try and draw a graph just to get an idea. I'm going to move this over here. Like this. So we're looking at these solutions. And I know that sine x is equal to 1/2 when x, so sine of x equals 1/2 when x equals, and then this is going to be pi on 6. A couple ways to remember this. I have an unusual method. I know the 3 values of sine x of the trig, so it's 1/2, 1 over root 2, root 3 over 2. And I just know that these are increasing, and so I know that the first one is 1/2, then it's 1 over root 2, and then it's root 3 over 2. And then I just know that the first one has to be that, and then the smallest angle is 30, which is pi on 6. So that means, actually I just realized I've messed this up. What am I doing? No, I didn't mess it up. I got mixed up with my x's. This is my x's. So what I know is that at this point, sine of x is equal to 1/2 for this pi on 6. This is pi on 6. And with symmetry, I know that this same amount, if I take this same amount, this, and I add it here, it's also going to be 1/2 because it's like symmetrical around the x-axis, right? Like you can flip it around, there's some sort of symmetry there. So I know that this value here is pi, and so if I add pi on 6 to that, I'm going to get negative 1/2. So the first solution of this is actually going to be x equals pi plus pi on 6 is 7 pi on 6. And similarly, if I go to the end here and I go back pi on 6, that means that I'm also going to get negative 1/2 because of the symmetry of this section of the graph, just this section here. So then I'm going to go 2 pi, which is this value over here, and I'm going to go back pi on 6. So that's 2 pi minus, so 2 pi, sorry, wrong color, 2 pi minus pi on 6, that's 12 over 2, so that's going to be 11 pi on 6. So those are our solutions for the second bracket. And now let's look at the first bracket. So cos x minus sine x is equal to 0, which means cos x equals sine x. Now this is a tricky one because we can't deal with cos and sine. We need either one. We need one trigonometric function. So what we can do is we can divide by cos x. So we're going to get tan x is equal to 1. The only problem is you can only divide by a function if you know that it being equal to 0 is not a solution. Because if cos x is equal to 0, then we can't divide by it, right? But just by quickly checking, we know that when cos x is 0, sine x is plus or minus 1, so they're definitely not equal. So we know that we can divide by it, but that's just be careful by dividing by. Be careful when you divide, because sometimes you can divide and you can actually cancel solutions, which we definitely don't want to do. And then for this one, you just have to know your trig values. So you know that x is equal to pi on 4. And then you also know that tan has a period of pi, so you just add pi onto that, so it should be 5 pi on 4. And quick reminder, actually, we're looking on the interval 0, is it less than? 0 is less than x, which is less than 2 pi. So we're just looking on this, the principal solutions. So if we add pi again, we're going to get 9 pi on 4, which is bigger than 2 pi. Similarly with this over here, there's only 2 solutions for sine x being equal to negative 1/2 on this range. So our final set of solutions is x is pi on 4, 7 pi on 6, 5 pi on 4, and 11 pi on 6. So those are our final solutions. And actually, I like to lay this out in a different way. It's just a bit messy here. I like putting the working out under each one, but because of this drawing, it's a bit messy. But in general, I like, so you do the working underneath each bracket, and it's very clear where each solution has come from in your working out. So hopefully that was clear. These are very tricky. I've had a lot of trouble with understanding these myself when I first encountered them. So let me know if you guys want to see more of these kind of trigonometric videos and what you want to see more of. I'll be making more calculus functions questions as well, so don't worry about that. But yeah, have a great day. And of course, as always, if you feel like you need more of this sort of tutoring, maybe in person, then feel free to head over to ThinkSmart Tutoring. You can grab a tutor. It's extremely flexible. You can pick your lessons. You can pick how long you want them to be. You can pick how often you want them to be, and hopefully, that'll provide some help for you to prepare for your exams. So yeah, feel free to head over to there. I'll be making more of these videos. Have a great day, and I'll see you soon.